Righto, in this video, I'm just going to go through a GCSE foundation paper. This, as we can see, is the Edexcel paper 3 from June 2017. I'm not going to do all the questions. I'm just doing a selection of questions. So let's get cracking. Okay, so first one I'm going to look at is this number 2 here. All right, so cups are sold in packs and in boxes. There are 12 cups in each pack. There are 18 cups in each box. Alison buys P packs of cups and P boxes of cups. Write down an expression in terms of P and B for the total number of cups that Alison buys. Okay, so well, if we just look individually, we've got 12 cups in each pack and she buys P packs, so that's going to be 12 P packs. Similarly, there are 18 B boxes and there being 18 in a box, and she buys B, so therefore the total cups is the sum of these two, 12P plus 18B. So that is the expression in terms of P and B. So we can see in terms of P and B for the total number of cups. Okay, so that is number 2. Let's just move on to number 4. 4/5 of a number is 32. Find the number. Okay, so we could form a little equation and do it with algebra. Here's another way of thinking of it, which is kind of more or less the same thing, really. So 4/5 of our number is equal to 32. So if we want to unpick this and go back from our 32 back to the original number, then what we need to do is we need to do the opposite things to the 32 to take us back to the, well, in this case, question mark. In general, we might say that we do the opposite things in the opposite order, but here we've only really got one thing, that's this multiplying by 4/5. So let's just have a look, do opposite things in opposite order. So our original number is equal to 32 divided by 4/5. Okay, so we multiply by 4/5 to get one way, and then to get back again, we're going to divide by 4/5. Now, the other thing to remember here is that when you're dividing by a fraction, that's equivalent to multiplying by its reciprocal. So the reciprocal of 4/5 is 5/4, 5/4. So our original number is equal to 32 times 5/4, which equals 40. Okay, so that is number 4. Number 5, a path is made of white tiles and grey tiles. A quarter of the tiles are white. Write down the ratio of white tiles to grey tiles. Well, we just have to think in terms of, we have to translate between fractions and ratios. So here, well, 3/4 therefore are grey, aren't they? Quarter of white, 3/4 are grey. So the ratio is 1 to 3. The ratio is 1 to 3 there. Okay. It's interested at all in betting, you might be interested to note that, of course, if something has a probability of 1/4 of happening, then the odds would be 1 to 3. So that's a kind of similar line of thinking. Just secondly, the 56 tiles, work out the number of grey tiles. Well, of course, if a quarter of them are white, then 14 are white, and that leaves 42 that must be grey. Okay, so that is that one. Let's just have a look at this one. Pretty's going to have a meal. She can choose one starter and one main course from the menu. Write down all the possible combinations. So we would, to do that, what we do is fix the first one and then go through all the different options on the second one. And then having done that, we then fix the second one on fish and go fish pasta, fish rice, fish burger, and then melon, and then with melon pasta, melon rice, melon burger. Now, if we had a third category, which was desserts, then what we'd have to do is fix salad, fix pasta, and then go through the different options for dessert. Once we've done that, then we change this one So it'll be salad, rice, and then through the 4 options for dessert, and just carry on and work our way through that. The main thing I just wanted to bring out here is when we've got 3 options here and 3 options here, then the total number of options, that's not what it's asking here, I know, but if the total number of options would be 3 times 3, as long as those options were independent. In other words, what we chose for starter didn't affect what we chose for main course. And then if we had, say, 4 different desserts we could choose, again independent, then the total number of meal options would be 3 times 3 times 4. So that would be 36, of course, which is how that would work. Right, so that is number 7. We're going to just scoot down to number 10. So this is another ratios question, basically. ABC is a straight line. Length of AB is 5 times the length of BC. Work out the length of AB. Okay, so it's telling us, if we just put it into sort of math speak, AB to BC is 5 to 1. That's what this is saying. Now we're interested, it's giving us AC, so really we need a ratio in terms of AC. Well, AC is the whole lot of this, isn't it? Here, so if AB is 5, then AC must be 6. So the ratio of AB to AC is 5 to 6. And if AC is actually in numerical value is 90, that 90 is 6 shares. Okay. So that would mean 6 times 15, that's 90. So each share, therefore, is 15, and AB would be 5 of those, which would be 5 times 15, which is 75 centimeters. And by the way, when you're expressing your answer, don't forget to put the units in the answer, and underline it as well, I would say. And here you've got a box to put it in. Right, number 11 then. T equals 4v plus 3, a little bit of algebra. Now, this is just a straight substitution. Work out the value of t when v equals 2. So we just write it out. Let's put our 2 in there. We can just work that through. 4 times 2 plus 3. Of course, using bid maths, we know that we're going to do multiply first. 4 times 2 plus 3, that's 11. And the second part is make v the subject of the formula. T equals 4v plus 3. Right, so just going back to what I was saying before, if we want to go back, and here we don't actually know a number for t, but we can do the same things anyway. So we can think of this in 2 ways. First of all, we can do a bit of algebra. So do a bit of algebra. We're going to do the same thing to each side of the equation. So first of all, if we subtract both sides, 3 from both sides, that's going to give us 2 minus 3 equals 4v. And then divide both sides by 4 to get this v on its own. So that'll be t minus 3 equals 4. So that would therefore be v is the subject of the formula. In fact, if it's on the right, it doesn't matter. It means it's on its own if it's the subject of the formula. The other way of looking at it is by saying, well, what have we done to our v here? We've multiplied it by 4 and we've added 3. So what we're going to do in order to get back is to take away 3 and divide by 4. So that's doing the opposite things in the opposite order. So that's essentially what gives us our v equals t minus 3 over 4 there. So it's two ways of looking at the same thing. I think one way, if you got a little bit of a thing about algebra, then yeah, you can perhaps think about it by reversing the order of things. Right, what are we going to do next? Well, we're going to move down to number 15, which is set theory diagram. So this curly E is basically means that it's the universal set. Everything, I think. What does it mean? I don't know. Odd numbers less than 30. and then set A is this and set B is this. So if we just map this out, we've got, well, there's the common thing between A and B is 15, so that's there. So that would put that in first, and then we can see that that's set A. Probably should mark A on and B on there in order to do it completely properly. 5 and 25 on there. And these are what's left over. Now, we mustn't forget these these things that are not in A or B but are in the universal set are an important set of things to put in your diagram. And we do note there are 15 numbers in total. So if a number is chosen at random from the universal set, what is the probability that the number is in the set A union B? Now, this is the union. If that's this little u is the other way up, it's the intersection, which means it's kind of this bit in the middle. But the union is the totality of all that's in A and B here. Okay, so so this lot is a union B, and as we can see, there are 7 numbers in there out of a total of 15. So if we choose a number at random, the probability that it's going to be in this bit will be 7 out of 15. Okay, that works. Okay, right. Move on to this one, which is simultaneous equations. It's just getting so further down the paper, so these questions are getting a little bit more interesting. Solve the simultaneous equations. 3x plus y equals -4 and 3x minus 4y equals 6. Now, that's the question. I've drawn this on here. So what I've done is I've drawn these two graphs. And the point is here that just to illustrate what we mean by solving simultaneous equations is that each of these equations can be illustrated by a line on a graph. So this first equation here, 3x plus y minus 4, by this line here. Now, what this means is, so this is on an xy coordinates, x horizontal, y vertically, is that on this line, if we take any point on this line, and it doesn't have to be whole number values, it could be, could be fractions or decimals, so we take the xy coordinates, say, of this point here, and we take those x and y values and we substitute them in that equation, then we will actually get the left-hand side is equaling -4. So we get a tick against our equal sign. And that indicates that that point is on the line. And that will be true for any point on this line down here. Take these coordinates and do the same thing. Okay, so this line represents all the points, all the possible points, infinite number of them that are on this line. And now similarly, this blue line is a representation of this equation. And we can see that these lines aren't, well, they're not parallel. The gradients aren't the same. We're not going to that now, but they do cross. And therefore, this point here is the only point on the whole thing where if we take the coordinates, put them into there, we get a tick, and put them into there, and we get a tick as well. Okay, so excuse me, any point on this line here that's not at the cross, if we put it into the blue line, into there, then it wouldn't equal 6. And similarly, any other point on the blue line here that we put it into the red equation, then it wouldn't get a tick. And if any point just out here in space is not on either line, it wouldn't get a tick for either of those. So there's one point here that we could say we can put the coordinates for this point in here, and we get a tick for this line, yeah, equals -4, and we put them in there, and we get equals 6. So we get a tick for the second equation. And that point is, the coordinates of that point are the solution to the equation. All right, so that's the general idea. And here I've written the equations down, numbered them 1 and 2, 2 equations in 2 unknowns. Now we can make this into one equation in one unknown, which we know we can easily solve. by adding and subtracting the equations, or indeed some multiple of one or both, which in other examples we may need to do. So if here, well, in this case, we don't really need to multiply them up. If we multiply an equation, we multiply each term, still the same equation, just scaled it up. But here we don't need to do that. I mean, we just take these two equations, and if we subtract the second one from the first one, then the 3x from 3x gives us nothing. Y minus 4y, and we've got two minuses there, so that's going to be 5y, equals minus 4, then minus 6, because we're subtracting, that's minus 10. So we've got 5y equals minus 10, or y equals minus 2. We take that y equals minus 2 and pop it back in there, that equation. So we're going to get 3x minus 2, that's for our y, equals minus 4. Then we can just add 2 to both sides of that equation. We get that, divide by 3, and that gives us x equals minus 2/3. Okay, now that's all good, because when we look at the point, which is x equals minus 2/3 and y equals minus 2, we go along minus 2/3, then down minus 2. Lo and behold, we get to this point of intersection. So we have found the point that that is on both those lines, and that is the solution to those simultaneous equations. Now, we eliminated x in this operation here. If we wanted to eliminate y, then if we multiply the first equation by 4, that's that equation, multiplied by 4, we get 12x plus 4y equals minus 16. So we've multiplied every term in the equation by 4. And then we can put it together with this second equation, we'll see that we've got this here. Now, we don't subtract here because we've got plus and a minus here. So if we add these two together, the y terms actually cancel out. We've got 15x on the left. And 15x equals, and on the right we've got minus 10. So that's, if we divide through by 15 and then simplify, we're going to get x equals minus 2/3. So again, we've this time we've eliminated y, we've got x. Again, if we take that x and put it back into one of the original equations, we will get y equals minus 2. In fact, it doesn't matter which equation we put it into. We will obviously get y equals minus 2. Okay, so that is that's simultaneous equations. So a little bit of a general bit of thinking about how that works and how you approach them. So in some situations, you may well need to scale both. You know, multiply one equation by 3 and the other one by 5 in order to get terms that you can then eliminate, whether it be y or x. And you can choose which is the most convenient. Right, we're going to just go down now and look at this question. Now, it's on regular polygons. This sort of question comes up all the time. Just position that right. The diagram AB, BC, and CD are 3 sides of a regular polygon. We can only see the edge, or the one part of it here. We've got squares that sit on these faces here. Show that polygon P is a hexagon. So this thing, we don't know. This is just part of polygon P. We don't know what it is. Now, the things, two useful things to know about regular polygons are about the angles. That's first of all. Let's have a think about the internal angle. So we've drawn a regular hexagon here, just to illustrate the point. Internal angles. Okay, so when we think about the internal angles, then what we do is, if we split this up into triangles, we've got 4 triangles, and in fact it's always 2 less than the number of sides. So we've got 6 sides. Then we've got 4 triangles, and therefore the total angles in this and inside this hexagon are going to be 6 minus 2 times 180, because 180 degrees in a triangle. that's 720. And if all the angles are the same and they add up to 720, then each angle must be 720 divided by 6, which is 120. Okay, so that's the internal angle of a regular polygon, and in this case, a hexagon, 6-sided. Now, think about external angles. Now, that's this angle here. So if we project aside and just kind of, which it turns, if you like. So now, if you can imagine you're driving a car along this this line, and then you come to do a turn, and then you do another turn, and then you do another turn, and then another turn, another turn, and then another turn. You've actually come around 360 degrees, haven't you? And since you've done that in 6 turns, and each turn, because it's regular, is going to be the same size, then one of those angles, and one of these are external angles, contrary to what it says, they're external angles, that's going to be each one's 360 divided by 6 equals 60 degrees. And if you notice, of course, we're talking about 2 angles on a straight line. That's the internal one there. This is the external. 120 plus 60 add up to 180, which is what we want and expect. Now, if we just look at the actual problem, well, what we can do here is we can say, well, a regular 12-sided polygon, what is the external angle? Well, 360 degrees, 12 sides. So each external angle is going to be 30 degrees. That's the external. Well, then we can, if we add this to this angle here, which it is 90, it looks like 90, doesn't it? But we could also follow the same thinking and say, well, that's the external angle of a 4-sided polygon, which is 360 divided by 4 equals 90. So that's 90 there. So we've got 90 add 30. That's 120. Now, this is an internal angle of a regular polygon. So we can work back from the angle, size of the angle, to the the number of sides. Well, there's a number of ways we can do that, but it does actually show that it's a hexagon. So if we just check what a hexagon, whether the angle of a regular, internal angle of a regular hexagon is, then we just follow this, subtract 2, that gives us the number of triangles, times 180, and then divide by 6, that gives us 120. So in actual fact, we've shown that the internal angle is the internal angle is 120, and therefore it must be a regular hexagon. Okay, so that could come in useful. Show that these 2 triangles are mathematically similar. Number 21. Well, if they're similar, then all the lengths are scaled by the same amount, vice versa. So we can see here that the 7.5 corresponds to the 3, just by multiplying 3 by 2.5. The same for 10, which is 4 times 2.5, and 12.5 is 5 times 2.5. So we can see that this left-hand one is a scaled-up version of the right-hand one, which is scaled up by a scale factor of 2.5. So therefore, we can apply the logic backwards and say, well, if they're scaled up by the same thing, 2.5 in this case, then they must be similar. Okay, so that is that one. And Harley's house has a value of 160,000, correct to 2 significant figures. Write down the least possible value of the house. Okay, well, what we've got to do here really is we're going to think that the possible things it could be, which and expressed to 2 significant figures, are going to be 150,000 or 170,000. Those are the ones on the either side. And then if we take the midpoint between 150 and 150 and 160, that's going to give us the lower bound, 155,000. So that will round up to 160,000, won't it? Anything less than this will round down to 150,000. Okay, so that makes that's the lowest it could be if it has been rounded to 160,000. Similarly, the highest thing that it could be is 164,999. So that will round to 160,000. But any more than that, then it will round up to 170,000. Now, there's just a little bit of a caveat on this, is that you could say the price might be 0.99 pence, and then arguably 0.99 recurring. So in some circumstances, we might want to consider that the upper bound is actually 165,000, because that's the same as 164.999.9999 recurring. But in this situation, it's a price. So I think we can say that it's going to be in pounds, isn't it? So so that would be the upper bound. And then the part B, the value of Rita's house increased by 5%. Her house then had a value of 210,000. Work out the value of Rita's house before the increase. Well, this is what we've done before. We've got the original price. We've multiplied it by 105%. That's 105 per, that's the line, per cent is 100, so 105%, and that's equal to 200,000. Well, of course, this itself is the same as multiplied by 1.05. So, applying our argument from before, if we want to get back to our original number, and it helps much, it does help if you write this down in, you know, like this, because it helps you to see it. So the thing we want is going to be equal to, well, the end result divided by 1.05. So basically doing the opposite in the opposite order. There's only one thing that we've done here, and that is this 1.05. So if we divide by 1.05, we can we'll see that's 200,000. Now, you know, we can do all that, and I think it's just worth saying that sometimes it's just worth having a guess on these things if you're not quite sure, or even if you want to check what you've got is right. Having a guess won't do any harm. I mean, if you guessed 190 and then you multiplied by you added 5% by multiplying by 1.05, then it would come out wrong, but you'd know that 190 is too low then, so let's try something a bit higher. So nothing wrong with having a bit of trial and error. But in this case, it's a relatively simple operation, as long as we understand what we're doing, which is we're reversing, you know, we're doing the opposite thing. Now, this is just like a bit of algebra anyway, isn't it? I put a question mark, but that could be an X, couldn't it? Or, you know, or a for amount or something like that, and that's what we've done. 200,000. Okay, so that is it. So hopefully that has been useful, and thanks for listening.